Hey there, we're MainMiller, a consultancy that helps teams and companies to adopt Rust in their engineering organizations. And we're also a new group of contributors to the Rustacean Station community podcast. We're going to be releasing a number of interviews with great authors and people using Rust professionally over the coming month. You can also find a link to the video of the conversation in the show notes. Enjoy! Hello everyone, I'm Marco from MainMiller. I'm joined today by Rob Ede, maintainer of Actix, one of the most popular web frameworks in the Rust ecosystem, and lead engineer at Kraken. Thanks for joining me today. Would you like to introduce yourself a bit?
Sure, yeah. I'm Rob. I'm born in the UK, live in London right now, and as Marco said, I'm a lead Rust engineer at the financial exchange Kraken. It was my first job out of university, actually, and I've been with the company for about 4.5 years. So it's been a real sort of journey for me, seeing it grow as it has with the industry in the last 4 or 5 years.
I think everybody's excited about Actix also, because it's certainly, as I said, it's like certainly one of the most popular frameworks in Rust, but still maybe some people are not aware what it is. Could you maybe give a 1-minute intro to Actix?
Actix Web is probably one of the first big web frameworks that appeared in the Rust landscape. It was created by a guy called Nikolay Kim, who through various situations left the project in 2020. The original concept of Actix Web was that it was built on this framework called Actix, which was an actor model implementation. At the time, the async landscape in Rust was pretty bad, so we had to use this whole alternate model of async computation, this actor model. For a long time, it worked very, very well. In version 1, that was entirely scrapped. Like, Actix Web is almost entirely unrelated to the original Actix project now, and that's one of the big misconceptions. But the founding principles now are just make a very fast web framework, pragmatic, ergonomic to use, and as fast as we can make it within those boundaries.
Could you talk a bit about sort of your history with the project, like how you got involved and so on? I would assume that has also something to do with your main job.
Yeah, so I think we were looking at converting some parts of the system at my work to away from what it was using at the time. So I was doing some research into what would be a good alternative for that, and I came across I'd already got some familiarity with Rust and came across Actix Web as it was and pitched it to the team, and they said basically, yeah, go for it, let's see what happens. So I got using it in the pre-version 1 days, and there was quite a lot missing. So as open source works, you end up filing pull requests and they get accepted, and then you feel like, yes, I'm part of this project now. Really, when it kicked off for me was in January 2020. There was a whole situation around Actix Web at the time, and the project got effectively removed from GitHub for a little while there. And I was part of a group of developers who wanted to fork the project and move it to a different name and provide basically an easy migration path for the many, many thousands of users of Actix Web at the time, and then continue developing it. What ended up happening was the repo was restored and new maintainership was given to GitHub user John Tita. And he never really officially renounced the lead maintainer role. But I got involved at that point. I was sort of ready to commit and stepped up to this contributor status and was pushing pull requests, weekly, more than once a week for various bits and pieces. We were trying to get Actix Web in this state of being ready to almost re-release as this safer framework. A lot of the problems with it had been related to safety and unsafe code beforehand. Mm-hmm. And really that was my task, my self-appointed task from like January 2020 up until the release of version 3, which I think was I think it was September. But in that time frame, it had become sort of clear to John Titor that I was kind of pushing a lot of this stuff forwards, and he gave me maintainership rights and push access to the crates repo in July or something like that. So during the beta period, I was able to start pushing the actual releases of Actix Web. So that's when I kind of started saying, like, it's on my head at this point. So I can call myself lead maintainer now. Yeah, the core team still consists of myself, John Titor, and another guy who's kind of an administrative admin for the org.
Yeah, I see. And I mean, all the work really paid off, right? Like now, sort of Active Web is certainly one of the most widely adopted like frameworks in that area in the Rust ecosystem, right? So that's that must be pretty rewarding.
Yeah, and I guess even in the last 3 years, since 2020, there's been a huge increase in the number of users of Rust, and at least some percentage of these people need a web framework. So if it had died back then, it would have nowhere near as many users as it does today.
You said earlier that sort of the original motivation for sort of using Actix Web at your work was you wanted to replace an existing solution, and I assume performance played a role in that sort of requirement and that search for new things. And then could you talk a bit about sort of where you were coming from and sort of what problems you tried to fix and then actually did fix with Actix?
Yeah, sure. The previous system that we had was based on Java, and if you're familiar, the system is a financial exchange, which is pretty sensitive to things like latency. Our clients really care about being able to, get their order in the book faster than the other guy. That means they can make money, and we need to facilitate them being able to do that. Latency is key here. So the previous system built in Java, what we'd find is that we ran into issues with the garbage collector mainly, and that you'd have these hiccups, these pauses when the garbage collector needed to do its work. And you would have clients ring us up saying, why did my order take 100 milliseconds to go through? Like, they'd notice, they really would notice, because, money is on the line with this stuff. So the plan as it unfolded was to try and replace all the parts of this monolithic Java service with microservices written in Rust. We're still yet to see that vision, but the parts that have been split out into Rust have seen massive performance improvements and massive drops in like memory usage. Again, the garbage collector is quite heavy on collecting memory and keeping it in scope for much longer than Rust needs to. So that makes the memory requirements of any Java web service quite a lot higher, which we noticed.
And before settling on Rust, did you sort of evaluate any other options like C++, Zig, or anything like that?
I don't think any of the team really knew C++ enough to get involved with that. And I think we kind of understood that it would be a downgrade in maintainability from Java. I'm not sure Zig existed. Correct me if I'm wrong, but
maybe not. It's really new, right?
This was kind of mid 2019, so I'm not sure that it was around. The options were, I don't know, from sort of an enterprise perspective, what is the alternative to Java, right?
For these kinds of things, Rust is really the only option, right? Because C++, in theory, you could have the same thing, but it's like Torvald said, like juggling chainsaws, right? If you don't have like a super experienced C team, it's really not something you can dare to try at all.
Yeah, that definitely feels true.
And I guess specifically the rest of the team, I guess you had some people switch from Java to working with Rust then. How was that experience, like for you and other people? Because I guess it's quite different, like working on Java before and then switching to Rust, right?
Yeah, right. I think we had a bit of an advantage that a lot of the team had heard of Rust and like maybe tinkered with it in the past, so they already were kind of sold on the idea of why it would be better. But obviously, I think everybody at the company at the time needed to actually learn it in order to really start using it. And then, of course, we started hiring Rust devs and testing on that and making sure that, yeah, the knowledge barrier was already crossed before getting them in the door.
Yeah.
Which I guess was its own challenge. But
what are the main benefits you get from Rust at Kraken?
Some key points, like some real tangible things that we've seen a reduction in cost. And I think this comes hand in hand with the efficiency story, but it's kind of the other side of the coin. If you can make your software more efficient to run, you can vastly reduce your hosting costs. If you reduce your memory usage, as we saw with our WebSocket gateways, used to be Java, are now Rust. We were able to not only reduce our AWS bill by a significant amount because we no longer needed these huge instances to host them on. We were also able to scale horizontally to more instances and therefore serve more clients as we grew, just without having to worry about the massive bill that would come with that scaling factor, because our memory usage per instance went from something like 4 gigabytes to 400 megabytes or even lower, right? Because it's just, it's that kind of scale. And I think this should be one of the driving factors behind Rust adoption at a corporate level. People joke about AWS bills being huge, and they can't get there.
Yeah.
And if you have your software written in a language that allows you to lower that, then for us, a no-brainer, right? So that's sort of the concrete side of it. I think there's an aspect of developer productivity that you don't see at the beginning. But if you're hiring people who already know Rust, and then they're at a certain level of like the exponential curve, right? If they're already here, then they're going to be doing really great work for you. It's hard to find these people, but when you find them, you can make software very, very quickly.
Or where do you think is the tipping point, sort of where someone gets like goes from being slower with Rust to being faster with it compared to Java or whatever they did before? Is it like weeks, months?
When they can explain the pin type. No.
Okay.
No. I think that's really hard to quantify. I think we have sort of a set of interview questions that include actually things like that, but yeah, I'm not sure really how to answer it in a serious manner there.
I guess it depends on individuals as well, right?
Yeah, if your panel understands Rust, then there's kind of a feeling of whether the person that you're interviewing has a good knowledge base of that.
In terms of benefits, obviously, like performance and efficiency is a huge benefit, but do you also see improvements, for example, with respect to errors in production, or so, where like in Java you have like null references and all that stuff that you don't have in Rust, right? Is there like do you see a noticeable difference in these things as well?
Absolutely. Null pointer exceptions were kind of the bane of our existence back in the Java days, especially plain Java. If you're not using Kotlin or anything a layer on top of the JVM, it's hard. It's hard trying to mentally get your head around everything is implicitly nullable all the time. Like there's no opt out of nullability. You have to, if you care, you have to check it. And if you don't care, you have to like document that it might be null when it's passed in here, and then do it. It's just a mess, mentally taxing. And these kind of things propagate up the stack, and you get really bad errors when it gets printed out in production, and you have to figure out where the heck where's this null pointer come from? Yeah, right? Because if some parts are accepting of the fact that things are implicitly nullable and some parts aren't, then there can be a large section of code that is like, okay, null, 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 null. Oh, I didn't expect a null over here, when actually it was generated all the way back in the stack over here, right? Yeah. And this is just such a pain. But yeah, I think one of the greatest decisions that Rust made is not to have implicit null and to have this explicit option wrapper, which really serves its purpose in that you should be handling this. And if at any point you can tell where the exception happened or where the error happened, that it is none and not some, at the point of unwrap, not way down the line when it's been passed into functions upon functions, right? It's here, this one.
Would it be fair to say then sort of that your Rust services are not only faster but also more stable than the Java services they replaced?
Absolutely, yeah. it makes code review, like to start at the beginning of the chain, it makes code review easier for us, which is less mentally taxing. It's easier to just read the code in the diff and understand what's happening and be sure that it's not going to break. And then when you deploy it, you can be more confident that it's going to last. It's probably not going to have crazy memory leaks. You can just leave it running. And certainly some of our services now have been running for months and months, and I've forgotten about them, and that's fine. Like, that's not a problem.
Yeah, that's the great thing, right? You ship and then you don't care about that stuff anymore, right? Well, with other things, sort of you do care, and you do get back to that stuff after shipping, fixing bugs and so on, right? I mean, we talked about what's great about Rust, but I'm sure there's also some problems and some shortcomings, and I'm sure there's also a lot of stuff that you would like to improve in Actix Web, for example, right?
So I think there's different perspectives to be had on this question of what's not great. One of the perspectives is as somebody who's new to the ecosystem, coming in from Python, Django land or Ruby, who's been doing like Ruby on Rails.
Yeah, that's very different.
Yeah. but these people exist, right? They come in,
sure.
questions in the Discord servers, and we have to answer like, sorry, this particular part isn't fantastic. One of the parts that these people seem to care about is having an all-encompassing web framework that has ORMs, templating, like the fully batches included kind of web frameworks. I don't personally care for that style. I prefer the micro framework kind of model that Actix Web is. That's a real missing piece of the ecosystem right now. Yeah, they also seem to be concerned about things like stability, especially if they're coming from enterprise level software, which I think we signal with this like version 1 thing, and we stick to semantic versioning quite well in the Kraken ecosystem.
Also, you mean API stability, not runtime stability, because that should be a concern,
right?
When
Actix,
right? Yeah,
I think there's so many fundamental crates in the ecosystem that are marked version 0.3 or pre V1, and people look at this and go, so it's not ready for prod then? It's like, but yes, it. How do we explain this? Yeah,
and the same people are happily using a node with version 14 npm packages that still break constantly, right?
I mean, maybe that's just something we need to get better at explaining, or maybe we need to accept that there will be a version 2 of our library one day. Like, that's not a bad thing.
And I mean, overall, sort of the state of the ecosystem is sort of like I think the Rust ecosystem is just at the point sort of where it has reached sufficient stability to be used in certain environments.
Yeah, absolutely.
It's not that we're not there, but also we haven't been there for a very long time, right? So if it's like about now is sort of where that point has been reached, I guess, right?
Right. Yeah. So I think that's the external perspective. The internal perspective, the people who understand Rust and write these things day to day, who understand the problems, have been frustrated by the lack of progress in things like certain common trait abstractions that we really want to be standard, like the stream trait, like the async read trait. People in my situation, I write libraries based on these traits, and I want to interop with other libraries that use different versions of effectively the same trait, but they're not compatible because, strong typing. So this is hard, and things like certain language features missing, like async traits, these parts actually leak through to the consumers of the libraries, and it makes their lives difficult. So not having async traits means that, Actix Web, things like extractors, if you want to write a custom extractor that does some async logic, you have to hand roll a future, which is really not the thing to do in 2023. People hate writing hand rolled futures, or you just box the futures completely, and that has certain restrictions that make it really frustrating to write these things. There isn't a good workaround for this yet, and we've been waiting for, firstly, like generic associated types, which landed pretty recently, and also just like the full fat async trait feature. We've been waiting for that for a long time, but that's really going to improve the consumers of these libraries' development experiences, because they can have the thought of how it should look and then just write it, instead of having to like convert it into this weird future implementation.
And that should also like make everything more approachable, I guess, right? Because I don't know, like for someone coming from Ruby on Rails or so, having to deal with like a 5,000 character long type in a Rust error message can be challenging, I guess, right? You hear a lot of feedback from people who have used Rails and so on before, like things that are very, very different, right? Do you like generally feel sort of they are able to make the switch, or is it like something that's really hard for these people that come from a like completely different world, like where you also don't even have the problems that Rust fixes for you, right? Like memory safety and all of that kind of.
Yeah, that's a really hard question to answer, because I guess all we see is the questions that they ask in the Discord, and then they're either satisfied with the answer or they throw their hands in the air and say, "Now I'm going to go back to Ruby." Like, I don't think we have that kind of information. What we do have is, I guess, numbers of people using Rust is going up, and it's not because there are suddenly more developers in the world, right? I think the people are staying, so people are willing to generally accept that these limitations exist right now and that they will be solved at some point. That's my hunch, but yeah, we don't have data on this.
That increase of people using Rust, like, does that also reflect in an increase of people being involved with open source in Rust, like Actix or outside of Actix maybe? Do you see sort of an increase of activity there?
An increase in contributions probably is true. When I sort of took over the maintainership, there's been more, I don't want to say low effort, but just like documentation improvements and these kind of like chores and small things from people who want to get going and are asking for a label that says good first issue just to help out. Like, I think people want to do this, but a lot of the real nitty gritty code is kind of inaccessible for a lot of the reasons that we've talked about already.
Yeah, okay.
It's really hard to contribute to that kind of thing.
Yeah, that's also related to the fact that sort of we at Main Meta, we made a bet on Rust, right? Because we think that general adoption of Rust in web projects will probably improve over the next few years, with like more teams choosing to build web servers of any kind in Rust for like improved performance, obviously, improved efficiency, using fewer resources to do the same thing, but also reliability, maintainability. And we think sort of that space is going to grow over the next few years, right? I would really be interested in your thoughts about that. And I think that also relates to what we discussed before, where you said sort of if certain things get fixed in Rust, the language and so on, that's going to make things easier and more approachable for more people. So I think that would also foster adoption.
I think one of the common through lines, one of my biggest pieces of rhetoric is that we need to improve ergonomics of these libraries that people are expected to use. I give the example of Express.js in Node-land because it has a very defined signature that all the handlers need to use. But the extractor pattern, which is used in Actix Web as well as Axum, actually makes it incredibly easy to get pieces of data out of the request in a type safe and a really beautiful almost way. It is ergonomic to use extractors, and it's through the power of some language features that this is even possible that don't exist in JavaScript. So that's a real big win for like adoption. The Hello World example on your homepage needs to be small. It needs to be understandable without you really knowing anything about Rust. And you need to make this, library authors like me need to really focus on that point, because if you don't have good ergonomics, people are going to get frustrated. They're going to see compile errors all over the place. They're going to leave.
So would you see a future where sort of Actix Web or other frameworks in Rust can be as approachable or similarly approachable to something like Express.js, but at the same time giving you all of the benefits of Rust, so for free, essentially, like zero cost abstractions?
Yeah, I think that's definitely possible. At the same level of abstraction, the micro framework kind of model that I would describe Express and Actix Web as, I think we do a better job of ergonomics in a lot of areas, except for, as I think previously mentioned, async traits. Their async sort of ecosystem is much easier to work with. promises have been around for forever and are simple to use. You don't need to worry about a lot of the things that you have to worry about in Rust. What we want to get to is a point where you don't have to worry about a lot of language details in order to write good software. And we're part of the way there. I think if you're using some off-the-shelf middlewares and extractors and stuff like this that we've already written, it's a very good experience. It's when you start needing to do customized stuff, as always, that things start to show cracks. Yeah.
But I mean, for that, like I think for those things, sort of with Rust, you get more guidance because of the types for building these customized things than as opposed to Rails or so, where you have no idea what you're doing at all, right?
Yeah, of course.
Awesome, great. Yeah, like I think there's a bright future ahead, right? Like if you can end up with something where sort of you get all of the benefits from us with like similar approachability to something like Express or Rails or so, I think that would be an awesome situation, really. And I think also kind of what we are betting on, really, with our bet on Rust that I mentioned before.
I think on Rails, like that level, like the bigger framework, the batches included stuff, I'm not aware of any real serious attempts to make something at that level. I think that's a lot to do with the versioning of stuff is still pre-version 1. You'd have to piece together 5 or 6 major crates in order to even begin to get to that sort of level. You know, you've got templating, you've got database layers, you've got background tasks running, you've got like all the parts, right? Which even some of the parts don't have very mature libraries for yet. Yeah. So if you're expected to bump your version as this like wrapper framework for every time one of your dependencies bumps its version as you're supposed to do in the flavor of Semver that we use, it's just going to be very unmaintainable.
I think that's maybe the next step in, I don't know, a couple of years or so, right? Eventually you need something like that. You mentioned before sort of you're more for sort of the micro frameworks, but I think eventually if you want to have like real wide adoption, you need something that like covers all of the things you need to do in a real app, right?
Yeah, I agree. I'm not one of the people who's interested in looking at that yet because the pieces aren't mature enough, or the pieces we're still figuring out these core abstractions. We need to figure these out first before we even think about the higher level stuff.
Sure, but eventually we'll get there, and then it's going to be a nice place to be for the Rust ecosystem. Can you share what you're working on in Actix right now and what's coming?
I've actually been doing quite a lot of work in the crate that I created, Actix Web Lab, and this is serving as a really nice test bed for things like new extractors and new ideas for traits and just types and middleware that will eventually make their way into Actix Web. Some of these things will require breaking change, so it's also nice to have a little companion crate for things that I don't think is worth making a major version bump for. Actix Web itself, obviously, V4 has been stable for over a year now, which has been one of the more proud things I can say about the V4 cycle. That was one of the real aims, and it's why it was in beta for so long. There will be a V5 at some point. We have some real incentives coming down the line for that. In particular, like I said, generic associated types and async traits. That'll be a real fundamental breaking change to a lot of the types that we're using. I'm currently working on an alternative service trait, which will effectively power most of the architecture that you either see or don't see, depending on whether you write middleware or not. That's in a separate place. Most of it is not published yet, but a lot of these fundamental abstractions need updating as the language features get updated. So I'm very excited about those.
And will those changes that are coming in V5 also sort of contribute to making things easier and more approachable?
Yeah, they should do, especially the async trait stuff. There's also just a couple of annoying decisions you make in any version that you can't roll back because it would be breaking. So I'm excited to get rid of those to-dos.
Yeah, it's always relieving, right?
I kind of have started adopting some of the third-party crates that seem unmaintained or because they're still using version 3 or something like this, but they also have good names and easy names to find if you're just typing in crates.io. I'm really trying to make the ecosystem of first-party Actix crates bigger, which is not great for my to-do list, but it does feel like the right move to give people assurance that the software they're using is going to work, it's high quality.
It's going to be great for stability, right?
Right, yeah. Discoverability, stability, and because it comes under the Actix banner, we're also able to, give people a good range of things to work on. Like these are the good first issues for this particular crate, and it's very easy to get involved with a lot of these like extractor crates that exist in the Actix extras repo. That's kind of where I point people usually if they want to get involved with the project. Because I think I'm working on like a first party rate limiting crate right now, which feels like something you should probably have first party. Stuff like that, expanding the first party ecosystem, I'm very excited to keep doing.
Do you have any recommendations for companies looking to adopt Rust?
John Jengsek gave a very good talk at Rust Nation, and it was called Living with Rust Long Term. And I think actually it was a good title, but my takeaway from it was this is kind of how you should look at Rust if you are adopting it into an existing organization. A lot of the points he made about sensible defaults, especially, and how to like get up to speed without having to fight lints, fight the compiler about a bunch of stuff that you really don't care about. Our background of growing with the language is kind of like, this is what we want to do. We want to like agree with the compiler on everything. But if you're transitioning some software, you don't. You want to throw away most of the lints that it's going to give you. So go watch that talk and take on board what he's trying to say, because a lot of it really, as I say, applies to orgs adopting Rust.
Yeah, so I guess that's a nice summary as well, right? There's a bright future ahead for Rust. I think we're all excited to be a part of that.
Yeah, I think you've made a bet, and I've also made a bet on my career to get stuck into this as well. So I definitely believe it.
I think that was a great conversation. Thanks for joining me today, Rob.
Oh, thank you.
Thanks for all of your work on Actix. Much appreciated, and many people benefit from that.
Yeah, good. See you at Eurorust.
See you at Eurorust. Yeah, that's a very good point. There are still tickets available, so make sure you get yours. Thanks, Rob. Speak soon.